In this video lesson, we're going to explore how to use our basic right-angle trigonometry to solve for angles. This is important for us in Math 10 because Chapter 2 of our course deals with trigonometry, and solving for angles is a basic trigonometry skill for this course. In order to successfully solve for angles, you need to be able to identify the hypotenuse as well as the opposite and adjacent sides in a right-angled triangle. And using that information, you need to be able to choose the correct ratio for the situation, then set up an equation based on the ratio, and just like solving for sides, in order to be able to successfully do this, you need to be able to algebraically solve equations. So let's imagine that you need to find angle D in triangle DEF, and since this is not drawn to scale, we can't use a protractor. To start with, we double check that this is a right-angled triangle. And now we're going to identify that we have an opposite side of 3 across from that angle D, and that the hypotenuse, together with this side that is 4 units long, makes angle D, so the 4 units long side must be the adjacent side. Based on this information then, we know that we should use a tangent ratio, and that the tangent of angle D will be equal to 3 divided by 4. Our problem is that we need to know how to undo tangent. When we need to undo dividing, we multiply. When we need to undo squaring, we square root. When we need to undo tangent, we use inverse tangent. The job of inverse tangent is to undo a tangent and leave the angle all by itself. And notice that inverse tangent will also sometimes be called arctangent, especially for students who are planning to study pre-calculus next year. So in order to solve for angle D, once we know that we're setting up an equation involving tangent, and we know that we are using inverse tangent to help solve, we show this rearranged equation with D equal to the inverse tangent of that original ratio that we set up. On our calculators, inverse tangent is the same color as your second button and just above the tangent button. So pushing second and then tangent will give you inverse tangent on screen, and then you can type in your ratio, including using the division button. So in this case, we find out that angle D is going to be approximately 36.9 degrees. Before you watch more of the video, take a moment to hit pause and make sure that you can find the inverse tangent as well as inverse sine and inverse cosine on your calculator and complete the calculation that you see on screen. In this second example, the instructions are to solve the triangle. When we see this word solve as an instruction, it means that we are going to find all the missing side lengths and all the missing angles. So in other words, for this triangle, we want to find the length of the hypotenuse. We'll call it little m since it's across from the big angle M. We also need to find the measure of angle K and the measure of angle N. Finding the length of the missing side is pretty straightforward. It's a Pythagorean theorem question, and we're pretty good at those, so we don't need to spend time on how to solve for that side. What we'll start to focus on is solving for one of our angles. Let's start with angle K. For angle K, we have an opposite side. The side that's 9 units long is across from K. Now we also know about two other sides, but I'm going to choose to use this side that's 13, the adjacent side. It forms angle K, but it isn't the hypotenuse. And the reason that I'll pick these two sides is that they were given to me in the question. If I've made any mistakes finding the length of the hypotenuse, that mistake won't affect my calculations for angle K. Now that we've identified an opposite and an adjacent side for angle K, we know that we will use the tangent ratio, and we set up our equation, that the tangent of K is equal to 9 divided by 13. And now to get K all by itself, we are going to use an inverse tangent, and we show what we're going to type into the calculator. With the help of our calculators, we find out that angle K is approximately 35 degrees. Now we have two options for finding angle N. Some students might choose to set up another tangent ratio. In this case, noticing that the tangent of angle N is now going to be equal to 13 divided by 9. Other students are going to notice that we can calculate angle N by subtracting the two angles that we know from 180 degrees. We know about a 90-degree angle, and we just found a 35-degree angle. So angle N is going to be approximately 55 degrees. Now let's take a look at this triangle. In this triangle we have an opposite side and a hypotenuse, so it's a sine ratio. The angle doesn't have a letter, so we'll use the variable theta. Now if we look at this, some students may very quickly look at talking about 6 dividing by 4 and setting up how the angle will be equal to the inverse sine of 6 dividing by 4. But when they move to their calculator, something kind of frustrating happens. If you were to type in the inverse sine of 6 divided by 4, your calculator talks to you about a domain error. And this is because the sine ratio is opposite divided by hypotenuse. You're telling the calculator you believe that the hypotenuse is 4 units long and the opposite side is 6. But your hypotenuse is always supposed to be the longest side. The domain error is your calculator's way of telling you you're asking it to think about a triangle that can't possibly exist. So let's try this again, but we'll set up our correct ratio this time and make sure that the rearranged version we type into our calculator also shows the correct information. The corrected work should look something like this. Remember, if you need to, hit pause so you can copy the example. When we work with our calculators now, we find out that this angle is going to be approximately equal to 41.8 degrees. Now that you've seen a few examples, this is a good time to test your own understanding. Hit pause after you copy this example in and see if you can correctly solve for the angle. Are you ready to see the correction? Here's what your work should look like. We notice that we have an adjacent side and a hypotenuse, so we use cosine, and check to make sure that you've included the original setup. Our next line of work shows what we're going to type into the calculator, the inverse cosine of 2 dividing by 5, and lastly we see that this angle is approximately equal to 66 degrees. If that's not what you found, check to make sure that we've set up the correct fraction and that we used inverse cosine. In this sample word problem, we're told that we have a tree that is 8 meters tall. Let's start out by sketching that. And our tree casts a shadow that's 15 meters long. Well, where do we see shadows? Shadows usually appear on the ground. So here's my shadow, and it is 15 meters long. It's probably a safe assumption that my tree is perpendicular to the ground. The last piece that we're asked about is this angle of inclination. The angle of inclination is an angle that's measured upwards from the horizontal. So our ground is horizontal, and our angle of inclination will be measured upwards, like this. It's also worth noting that angle of inclination may also be referred to as an angle of elevation, and that means exactly the same thing. In any case, we're looking at a diagram like this. So we have an opposite side, and we have an adjacent side. This is a good time to set up and solve an equation using tangent. In this case, when we fill in our tangent ratio with the unknown angle, equal to the opposite side divided by the adjacent side, and then we solve using inverse tangent, we find out that the angle of inclination of the sun is 28 degrees. In other words, the sun is approximately 28 degrees above the horizon. This last example also involves finding an angle of inclination or an angle of elevation, keeping in mind that they mean the same thing. Why don't you take a few moments and try to solve for this missing angle? Hit pause on your video until you're ready to check your work. Now let's see if we're on the right track. This diagram shows us an opposite side as well as a hypotenuse, so we're going to use a sine ratio. And I'm noticing as I set this up that my opposite side is very small compared to my hypotenuse. In other words, this triangle is actually very, very short, so we're not going to expect theta to be a very large angle. Once again, we make sure to show the line of work that indicates what we typed into our calculator, in this case using inverse sine, and we find out that angle theta is only approximately 1 degree. Hopefully by now you've developed a certain amount of comfort solving for angles in triangles, and will be ready to do some more practice when you come to class next day.